Zero and negative exponents. Lesson 7.3. You are watching this video with Ms.Y Cavazos. So, in today's video we're going to learn about zero and negative exponents because, guess what? They exist. So let's begin with the very first property that has to do with the zero exponent. So, any base that is not a zero, so the base cannot be zero, raised to the zero power will always be equal to 1. Any base, it doesn't matter what base you can possibly have. Let's say I gave you 12 to the power of 0. The exponent is 0. Guess what? The answer is 1. What if I gave you 172 to the power of 0? Exponent is 0. The answer is 1. So any number, any variable, anything to the 0 power will always give you a value of 1. So let's begin with some practice problems. Simplify the following expressions using the zero power property. So here we have a simple expression of h to the power of 0. It has a power of 0. That is the most important thing. So guess what? Plain and simple, the answer is 1. Next, we have a different type of expression that consists of 3 different bases, as you can see. So we pay a look at their exponent. We notice this particular exponent, it is a 0. Now, thinking about all the properties that we've done, we've added exponents, subtracted, multiplied. Look at these 2 bases. They're different. So do not think, oh, let's add the powers 0 and 5. You cannot do that because bases are different. What we could do is, okay, let's see. Bring down the 3. C to the power of 0 is just 1. And I'm going to put parentheses. Why am I putting parentheses around that? Because it is indicating that all of these are multiplying. We don't see the multiplication the multiplication symbol, but it is clearly multiplying. So that's how this problem really looks like. Everything is getting multiplied. So I'm going to use parentheses to separate the 3 from the 1, otherwise you're going to think it's a 31, and it's not. Next we bring down e to the 5th. Nothing we can do there, nothing that's happening to it. So in our final answer, what we could do is we could multiply those 2, and it gives us a 3. Bring down e to the power of 5, and there's nothing else we can do to this problem. We have simplified to the max. Let's look at this here. Okay. Here we have the scenario of the classroom, or the opera scenario. Okay. Think of this as a classroom enclosed. Something is being shared to them. So we're going to share it. Okay. This means that we need to multiply the exponent because f already has an exponent. So that exponent 11 you're going to multiply with 0. And same thing with the g. G has an exponent of 3 and we're going to multiply it with a 0. This gives us f to the power of 0, g to the power of 0. And then you got to remember, anything to the power of 0 is just 1. So this is 1 times, same deal with the g. G has an exponent of 0, so that's just 1. 1 times 1, 1. You're probably thinking, Miss, you made us do all this work for the answer of 1. Yes. And guess what? The answer was very obvious from the very beginning. If you look closely, what's the exponent of this entire parenthesis set? 0. So from the very beginning, you could have seen that the answer was going to be 1. But of course, this work here is a way of proving it. Next problem. So here we have a quotient. We have a fraction set up. So you got to stop and remember, what properties have we learned that we can apply here? Well, properties that deal with quotient have been, if the bases are the same and its division, what we are allowed to do is subtract the exponents. So that is exactly what we're going to do. This whole fraction, we're going to break it up so we can pay attention to these two things that are occurring. We have the base of x, numerator 3 divided by denominator of 3, the powers. So this is x to the 3 minus 3. On this side, we have the base of y, and we subtract the numerator power minus the denominator power. Okay, so we're going to simplify. X to the 3 minus 3 is x to the 0. Y to the 8 minus 4 is just y to the 4th. And then you say, okay, I'm done. But are you really? Think about what's going on here. Power of 0. We cannot ignore it. You will not see an answer ever that has something to the power of 0. It is your job to remember that that is just 1. What we do is bring down the y to the 4th, and our final answer does not need to contain the 1 anymore. You can just have y to the 4th, and that is enough for the final answer. Okay, so we got to start remembering properties from before that we're going to need. Okay. Next property and final property is the negative exponent. Negative exponents do exist. What do we do when we happen to have a negative exponent? So it says, is the multiplicate inverse of the base raised to the positive opposite of the power? What does that mean? So when you have an base raised to the negative power, what you're going to do is you're going to take the reciprocal. You're going to flip it, okay? So it gives us this here, and then the exponent is no longer negative. So that's what has to happen when we have negative bases. So let me give you a short example here. Let's say I gave you 2 to the negative 4. Well, you will never see an answer that has a negative exponent. So what we do is put this base over 1, flip the fraction, and the power is no longer negative. That's what has to happen when we have negative exponents. So now let's apply it to the variables. Same idea. We have w to the 3rd times w to the negative 8. Now before you say, oh, negative exponents, let's flip it. Hold on. These powers are getting multiplied. This goes back to a previous video that said, when we have powers of the same base that are being multiplied, we are allowed to add those powers. So we're going to use that idea to start off with this problem. Obviously, they're multiplying. So we must add 3 plus negative 8. Well, you need to remember, or you might have forgotten, that this 3 plus negative 8 is the same thing as 3 minus 8. Okay, so 3 plus negative 8, which is 3 minus 8, is essentially just w to the negative 5. We cannot leave our final answer looking like this with the negative exponent. So what we do, put it over 1, flip or take the reciprocal of your ratio of your fraction. Power is no longer negative, and we're done. That's the answer. That's how you will find it on a multiple choice answer. Okay. So let's try other examples. Here we have another problem. There's multiplication involved, so you should remember the product of powers property, which means add the exponents. So this 4, since it's the only coefficient, I'm going to copy it. Just write it there. Nope. The basis of z, and I'm going to write my z like this so I don't confuse it with the 2, we're going to add their powers. So 6 plus negative 14. And remember, this is just 6 minus 14. Same idea. Okay. So that gives us z to the negative 8 with a coefficient of 4. But we cannot leave our final answer like this. We cannot have negative exponents, so we gotta fix this up. Okay. So like I said earlier, when we have a negative exponent, we must put this over 1. Well, if we're gonna make that a fraction, guess what? We need to make the 4 a fraction as well. Now the only base that has a negative 8 is z. So what we're gonna do is flip this particular fraction, and it becomes 1 over z to the 8, and 8 is no longer negative. And we're going to keep 4 over 1. Do not do the reciprocal of that. Do not flip it, because 4 wasn't even negative power to begin with. So in our final answer, we got to rewrite this a little neater. Our numerator is the numerators here, which is 4 times 1, 4. Our denominators are 1 times z to the 8, which is just z to the 8. And this is our organized final simplified answer. Kind of tough to work out. You got to remember that we're using different properties. Everything that we've learned previously, we got to use it in these problems. We have to remember them and apply them. Next, we have an expression that looks kind of simple. It's dividing, so immediately you should think, oh, I'm going to have to subtract. So this means keep the base, take the numerator power, subtract it by the denominator power, and we get that this is h to the negative 2, which we cannot have, so we put a 1 under it, take the reciprocal, which means flip it. Power is no longer negative, and we're done. Next problem. So in this particular problem, we notice that there is a 12 in the denominator, and there are bases of x, both in numerator and denominator, so we're going to have to subtract those powers. So what's going to happen is x to the 4th minus 11. This 12, however, it is under a fraction, so we have to keep it under. But miss, how come there's a blank spot? There's nothing on top. Well, put a 1. Just like we can do 12 over 1. When it's a fraction and you don't have anything on top, put a 1. Next, we have that x to the 4 minus 11 is just x to the power of negative 7. Bring down the 1 over 12. This cannot be our final answer. So this exponent, remember, put it over 1. We're going to flip it. So we get 1 over x to a positive exponent, converts to a positive. Keep bringing down that same fraction, 1 over 12. Now this will not, you won't see your final answer like this. We gotta put these together, make it look neater. So in our final answer, we're gonna have 12 and x to the 7 as a denominator, and in the numerator, we're going to have a single 1. That's our simplified answer. Okay. Next problem. It's not division, but it is multiplication. So remember, when the bases are the same and it is multiplication, we are allowed to add the exponents, and that is what's going to occur in this problem here. I'm going to take the base of x, and that is x to the negative 6 plus 4. And I'm going to take the base of y, and that is y to the 3rd plus this y has a power of 1, so 3 plus 1. Okay, simplify. This becomes x to the negative 2, y to the 4th power. The one that has a negative power, put a 1 over it. We're going to flip it. Becomes 1 over x squared. Y to the 4th, however, is not a fraction, but if we make it a fraction, it's in the numerator. So in our final answer, we're going to have something in the numerator and something in the denominator. Well, this is our numerator, which is just y to the fourth. This is our denominator, which is just x squared. And that is our simplified answer. I'm going to go over two more examples. Okay, fraction, quotient means subtract powers of identical bases. So here we have base of b, so it becomes b, power of the numerator minus power of the denominator. And then we have base of c, so that means power of the numerator, which is negative 3, minus power of the denominator. So we end up that b, 5 to the 5 minus 2 is b to the third. C to the negative minus 4 is negative 7. And again, we're not done yet. Why? Because of this negative exponent. So put it over 1. We're going to flip it, which gives us 1 over c to the 7. B to the 3, if we make it a fraction, put it over 1. Our numerator, to put this answer together, our final answer will have b to the third as the numerator, c to the 7th as our denominator, and that is our simplified answer. Final problem. Okay, we look at this and we see, okay, bases of k, base of c, and then I have a 10 in the numerator at the top. So we're going to concentrate on the k's first. This is 7 minus 7. Then we have c to the negative 8 minus negative 5. Be careful with that. Too many negatives involved. And the 10 goes in the front. So this gives us k to the 0, c to the negative, and in case this confuses you, this is just negative 8 plus 5, which gives you a negative 3. And again, 10 at the top. So, two things here. We notice this has a power of 0, this has a negative power, so something has to happen. First of all, negative power, put a 1 under it, and we're going to flip it. Second, anything to the power of 0 is 1. So then we get that 10. This is times 1, so parentheses 1. And this becomes 1 over c to the third. After we take the reciprocal, we flip it. Our answer then proceeds to be 10, 1 over c to the third. Of course, you won't see your answer arranged in that way. What we're going to have is, if we make it the 10 a fraction, we will have that 10 will be in the numerator and c to the third will be in the denominator, and that is the proper way of writing our simplified answer. Thank you for watching this video with Ms. Cavazos.